The ICEVI, the Nippon Foundation Mathematics Package for Teachers video series, Abacus as a Mathematical Tool. Title of the video, Square Root of an Imperfect Square. Example, 24,697. Let us slightly alter the number 24,649, which is a perfect square, and consider 24,697, which is not a perfect square. And let us see how this can be solved. Set the number 24,697 in the right side of the abacus by leaving 3 columns at the extreme right. Consider the first group 246 and consider the highest perfect square, which is 225. Take the square root of 225, which is 15. Set 15 by skipping a column to the left of 2. 15 multiplied by 15 is 225. That should be subtracted from 246. Now, the number left in the problem is 2,197. In the next stage, double the square root part, that is 15, and set 30 in the extreme left of the abacus. Consider 3, the highest digit of the number on the left end, and 21, the highest 2 digits of the remainder. Ask how many 3's in 21. You get the answer as 7. We can go for an assumed quotient 2 by considering 6 to begin with. However, we can consider 7 also, as 21 by 7 does not give a remainder. We can always reset the number in case the assumed quotient is larger than the actual quotient. For the time being, set the number 7 to the right of the first 2 digits of the square root 15 and to the right side of number 30, which makes it 307. Now multiply 7 with 307 and the value should be subtracted from 2,197. That is 7 multiplied with 3, which is 21, and this is subtracted from the 21 and the remaining value is 097. In the next stage, we have to multiply 7 with 0, which is 00. That does not change the value, and the remainder is still 097. Now multiply 7 with 7, which gives 49, and that should be subtracted from the 97, which gives 48. Therefore, 24,697 is not a perfect square, as there is a remainder 48. Now you have to go for your decimal part of the square root. Add 1 0 to the dividend, which makes it 480. The mandatory 3 columns earmarked on the right extreme of the abacus are useful for carrying out the calculations dealing with the decimal part of the square root of a number. From here on, you can simply follow the regular division procedures in getting the decimal part of the square root. For getting the divisor, you can double the square root 157, which is 314. Since 314 is less than 480, your first decimal digit of the square root will be 1. Set that 1 to the right of the square root 157 and subtract 314 from 480, which is 166. Now add one more 0 to the dividend. Now you get 1660. When we are going to the second decimal of the square root, you can round off the divisor and get approximate values. Now 314, which is the divisor, can be rounded off to 300. And you ask how many 300 in 1660? By saying 5, place the 5 to the right side of the present square root and it becomes 157.15. Now from here on, there is no need to do further calculation as you are limiting the decimal part of the square root into 2. However, the 3 columns in the right are provided, assuming that one may go for higher number of decimal digits in the square root. Let us take up some more examples similar to this and demonstrate.